Diagrammatic presentation of data. Diagrammatic presentation of data gives an immediate understanding of the real situation to be defined by data in comparison to the tabular presentation of data or textual representation. Diagrammatic presentation of data translates pretty effectively the highly complex ideas included in numbers into more concrete and quickly understandable form. Diagrams may be less certain but are much more efficient than tables in displaying the data. There are many kinds of diagrams in general use. Amongst them, the significant ones are the following: geometric diagrams, frequency diagrams, arithmetic diagrams. A bar chart or bar graph is a chart or graph that presents categorical data with rectangular bars with heights and lengths proportional to the values that they represent. The bars can be plotted vertically or horizontally. A vertical bar chart is sometimes called a column chart. What is bar graph? A bar graph can be defined as a chart or graphical representation of data, quantities, or numbers using bars or strips. Bar graphs are used to compare and contrast numbers, frequencies, or other measures of distinct categories of data.
As two rows. In one, we write the sport, and in the other, we write the number of people who like the sport. The four categories are cricket, football, tennis, and others. Others would include all kinds of sports apart from these three. And this is the data we have. 10 like cricket, 13 like football, 2 like tennis, and 5 like sports which are other than these three. Now let's try to represent this data in an aesthetic way. Let's draw two perpendicular lines like these and mark 1 to 13 in equal intervals. We can use bars to represent the number of people who have watched a sport. The four categories are cricket, football, tennis, and other sports. We know that 10 people like cricket, so we draw a bar up to that height. 13 people like football, so we draw a bar up to the number 13. Remember, the numbers are written in equal intervals. Since only 2 people like tennis, we draw a small bar up to 2. And we draw a bar of length 5 for the people who like sports other than these three. Such graphs are called bar graphs, and they are called so because these bars help us analyze the data. But how do they help us? Ignore the table for the moment and look at the bar graph. Just by looking at the graph, we can effortlessly say that football is the most popular sport and tennis is not very popular. Mostly, these graphs are drawn on a graph paper. We will understand more about it in the next few videos. Let's see a practical example where the bar graph can be used to understand data more easily. This is a graph of average temperature of various cities. In this graph, we mark 10 degrees in equal intervals. And we have been given data for 6 cities: A, B, C, D, E, and F. Now, just by looking at this graph, let's try to answer a few questions. Here's the first one. Which is the hottest city among these 6 cities? Well, it's obvious. It's city F as its average temperature is highest among peers. Next one. If temperature greater than 25 degrees Celsius is warm, list the warm cities. This is the 25 degrees Celsius line. All cities having their average temperature above this line will be included in the list. So the warm cities are B, C, and F. Here's the last one. What is the difference in temperatures between the hottest and the coldest cities? The temperature of the hottest city is approximately 48 degrees Celsius, and the temperature of coldest city is around 9 degrees Celsius. So the answer is 48 minus 9, which will equal 39 degrees Celsius. Apart from helping us answer such questions, the most important way in which the bar graph helps us is that just by looking at it, we get an idea about each of the categories.
कहाँ आज धूप में गए थे? अब मंत्रालय से बोलिए हम लोग चाय नहीं पिला रहे थे।
That bar graphs are used to represent data aesthetically. But there are different kinds of graphs that can be used to represent different kinds of data. Say we want to compare the marks of Zen and Zara in 4 subjects: maths, science, English, and history. These are the marks they obtained in the 4 subjects. So to compare the performance of Zen and Zara, let us draw 2 separate bar graphs to represent their marks. We start off with Zen's bar graph. First, we draw the x and the y axis. Remember, you need to draw this on an actual graph paper. Once we draw the axes, we label them. As the size of the bar will depend on the marks scored, we label the y-axis as marks and the x-axis as subject. Then we choose a suitable scale for the y-axis. The numbers range from 35 to 46. If we take multiples of 10 on the y-axis, we would need just 5 centimeters, which is feasible. We can take a scale of 1 centimeters as 10 marks on the y-axis. We mark 10, 20, 30, 40, and 50 on the y-axis. Always make sure that the y-axis range covers all the data. We write maths, science, English, and history on the x-axis. Zen has scored 42 marks in maths, so we draw the bar accordingly. He has scored 46 in science. The bar will be slightly bigger than the one for maths. 45 in English and 35 in history. So we have Zen's bar graph ready. Now let's draw the bar graph for Zara. We follow the same procedure. We draw the x and the y axis. We label the axis and choose the same scale. 1 centimeter is equal to 10 marks on the y-axis. On the x-axis, we have the same 4 subjects: maths, science, English, and history. Let us use different styles of bars this time. Let's draw shaded bars. Zara has scored 40 marks in mathematics. We draw a bar up to the height of 40. She has scored a 46 in science, 40 in English, and 45 in history. We are done. Now we have the bar graphs to represent the performance of Zen and Zara in 4 subjects. So if you're asked to name the subject in which Zen has scored the least marks, you would say it's history. And the subject in which Zara has scored the maximum marks, you would say it's science. But quite often, we need to compare 2 sets of data. In this case, we may need to compare the performance of students. So just by looking at the graphs in isolation, would you be able to tell me who's performed better in maths? Or science maybe? It's a bit difficult. How about combining these 2 graphs? We just place the bars next to each other. We can take Zara's maths bar next to that of Zen's. Zara's science bar next to that of Zen. We do the same for English and history. Now we have both together. The white bars represent Zen's marks. The shaded bars represent Zara's marks. Now it's simple to compare the performance of Zen and Zara in these four subjects. In comparison with Zara, Zen has scored more in maths, less in history, more in English, and equal in science. This is called a joint bar graph. We represent two sets of data on one graph so that we can easily compare them. Three divisions: A, B, and C. Division A had 30 boys and 15 girls. Division B had 25 boys and 20 girls. And Division C had 15 boys and 35 girls. To represent the data diagrammatically, we will need to use two bar graphs. One for the number of boys in each division and another for the number of girls in each division. So we make the x and the y axis and choose a scale of 1 centimeter equal to 10 boys on the y axis. So we write 10 to 50, marking equal intervals of 10. This covers the data range for the boys of class 8. And we have divisions A, B, and C on the x-axis. Now look at this row. The number of boys in division A is 30. Based on the scale, we draw a bar of length 3 centimeters for boys of division A. Similarly, we draw bars of lengths 2.5 and 1.5 centimeters for B and C. 2.5 centimeters represents 25 boys in division B and 1.5 centimeters represents 15 boys of division C. Now let's draw the bar graph for the number of girls in each of the divisions. We choose the same scale for the y-axis and write A, B, and C on the x-axis. To represent the number of girls, let us use shaded bars. To represent 15 girls, we draw a shaded bar of 1.5 centimeters for division A. And similarly, bars of 2 and 3.5 centimeters for divisions B and C respectively. 2 centimeters represents 20 girls and 3.5 centimeters represents 35 girls. But do you know that there is another way in which we could have represented the data in this table? We have looked at joint bar graphs where the bars of two different categories were placed next to each other for better comparison. But there is another way to do it. As the scale is the same, we can just place these bars on top of these bars. Division A on A, B on B, and C on C. Now we have just one bar graph. These kinds of graphs are called subdivided bar graphs. How is this different from the joint bar graphs? We can see that this graph also tells us the total number of students in each division. Division A has around 45 students. Division B has also around 45 students. And Division C has 50 students. And looking at the different styles of bars, it helps us compare the number of boys and girls in one particular division. Just by looking at the bars, you can say that Division A has more number of boys as compared to the girls in that division. Division C has more girls than boys. Which is why, in a subdivided bar graph, it is always important to write the legend. The unshaded bars represent the boys and the shaded bars represent the girls. So these were the basic concepts about the subdivided bar graph. But how do we actually construct it? We will see that next. What subdivided bar diagrams are? We have the XY axis and bars with shaded and unshaded regions. We use shaded and unshaded bars to compare two kinds of data. But observe this graph closely. There's something special about this particular bar graph. The bars are subdivided, but of the same height. All the bars are of 100 units. What do we have on the y-axis? We have the percentage. So the scale would be something like 1 centimeter equals 20% on the y-axis. How do we read this graph? In the first bar, the shaded category comprises of 40% of the total bar size, and the unshaded region comprises of the remaining 60%. In the second bar, the shaded category comprises of 80% of the total units, and in the third bar, the shaded category consists of 60% of the total units. Remember, all bars of equal height which represent 100%. This is called a percentage bar diagram.
हमने देखा कि there are simple bar diagrams. You can read here. Different type of data may be requires different models of diagrammatical representation. You can read here table 4.2 or figure 4.2, figure 4.1, figure 4.1 bar diagram showing male literacy rate of major state of India in 2011, literacy rate to population aged 7 year and above. मल्टीपल बार डायग्राम्स भी होते हैं, कंपोनेंट ऑफ बार डायग्राम. You can pause the video and read the video. Next we will study about the pie diagram.